Okay, so in this video I'm going to be showing you how to do definite integrals with U-substitution involved. Now, the difference between these and regular indefinite integrals is that we're actually going to have to do something special with these two domain values that we are supposed to evaluate. I'm going to show you that in just a little bit, but before that we're going to notice how this is a U-substitution problem because you have 2x in the parentheses and it's not just x by itself. So we're going to go ahead and do U-substitution as normal. Going to set u equal to 2x, integrate, get du is equal to 2dx, and then to get the dx by itself, we're going to go ahead and move the 1/2 to the other side by taking the reciprocal, and then we've got 1/2 du is equal to dx. So when we go ahead and write out our u equation, f of u, we can go ahead and pull out the 1/2 and put it on the outside, and then we have the integral of, as you can see, the difference here is that it's 4 pi over from 2 pi over 3 to 4 pi over 3, which is different than what we had originally. Basically what happened is we took each of these values and we plugged them into the 2x to get the u approximation of it. So we're going to get the 1/2 times the integral of 2 pi over 3 to 4 pi over 3. You need to remember to change that because that's a mistake a lot of people forget to correct. So then when you get the integral of the u, you're going to go ahead and evaluate it, and you get f of u is equal to 1/2 times the negative cosine of u plus c. Simplify that sum, and you get negative 1/2 cosine of u plus c. Now, one more thing you have to do before you go ahead and write this in terms of x again is because, remember, we're not solving for u, we're solving for x, is you also have to, since this is a definite integral, and it's kind of like the FTC where you evaluate it, you're going to have to put the bar, and then 4 pi from 2 pi over 3 to 4 pi over 3, which are the two u values that we had over here. But you're not going to evaluate that because we're not solving for u. It's just something you have to do to show that this was in terms of u and not in terms of x. I don't know why, but that's just the way it is. So we're going to go ahead and rewrite this in terms of x. F of x is equal to negative 1/2 cosine of 2x, because u was 2x, plus c, and we're going to go ahead and evaluate this from our original values, which were pi over 3 to 2 pi over 3. That was the domain of the x's. So when we go ahead and plug them in, there's all that. Just plug in 2 pi over 3 minus 1/2 cosine of 2 times pi over 3. Simplify, you get all this, even more, and then it just ends up being 0. So this part you can all do by yourself, but the main thing you need to remember is that you need to remember to rewrite the domain in terms of u. So when you go ahead and do f of u, you got to rewrite the domain on the integral sign, 4 pi over 3 and 2 pi over 3, and then do it one more time before you rewrite it in terms of x right here. And that's it.